Okay guys, back to the next question. So here is another limit as x approaches 2 of 6 minus x square root minus 2 over top of x squared minus 4. Now, my trick of factoring difference of squares isn't going to help you here. Now, there is a difference of squares. We're going to be interested in that, but the top, yeah, not so much. So you're stuck here. You need to do the rationalizing technique here. You have to do the rationalizing. So the top is the part that's irrational. So what I need to do is multiply the top by its conjugate. That is the conjugate of the top. And the bottom, to make sure that everything stays equal, has to be multiplied by the same thing. So this whole thing is actually 1, and we're going to multiply it by our other factor, but the overall value of the expression doesn't change. It's going to look very, very different though. So there's a reason why I set this up. This is a minus b, a plus b, which means it's going to be a squared minus b squared. And I'm not going to waste a lot of time doing the FOIL method or the rainbow method or whatever you guys called it. By the way, its proper name is the distributive property. That's it. You call it the distributive property. That's it. Anywho, I got root 6 minus x times root 6 minus x, which is 6 minus x. And then I've got minus minus, which is going to be minus. And then I got 2 squared, which is 4. All over top of. Now, if you expand out the bottom, you're not thinking. You're really not thinking. I don't want to expand the bottom. I'm looking for factors in the bottom. And in fact, I'm looking for a 0 factor. So anything that does factor in the bottom, I probably should do it. So I'm going to do it right now. Extend that line. If that line doesn't cover everything in the bottom, I'm going to be upset. I'm going to take marks off. So what happens in the top? I've got the limit as x is approaching 2. I've got 6 minus 4, which is 2 minus x, over top of x minus 2, x plus 2, 6 minus x plus 2. And notice I put a little downward arrow on that, so you see where it stops, and notice I extend that. Well, my 0 term, this is definitely a 0 term, got no problem with that. This is definitely a 0 term, got no problem with that, but they ain't the same term. They got the same 2 and x in there, but one's positive, one's negative. We got to get those signs lined up. So we're going to common factor out of -1. So I'm going to common factor out of -1 out of the top. It's always easier to take it out of the top. So it's going to be x minus 2, x plus 2, 6 minus x plus 2. Now, if you really want to, you can take some time and rearrange this and make it x minus 2 so they look so pretty. But the truth of the matter is that and that are the same thing. So now I'm going to let the limit take hold. I'm going to go and start the limit. Ring-da-da-da-da-ding. I'm not sure why that's the sound for a limit, but that's the sound for a limit. Ring-da-da-da-ding, ring-da-da-da-ding. So x is now approaching 2. Brum, 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 brum. -1's on top. It doesn't care what happens as x approaches 2. This one cares what happens as x approaches 2. The whole thing's going to go to 4. This cares what happens as x goes to 2 because the radical, or the radicand, sorry, the thing underneath the radical sign is going to go to 4. The square root of 4 is 2, plus 2 is 4. So now we're going to get an answer of -1 over 16. And until I initiate that limit, I have to write it everywhere through. But guys, if you were to do this, if you were even to think of doing this, if you were even to contemplating putting in the limit after you put in the value, my red pen will come out and it'll go like that and it'll be just so sad. There'll be unhappy people everywhere. Once I put in that limit value, you no longer write the limit. Okay? All right, let's stop there and we will be back in